to show you how this works animated so you can see how all these parts fit together and how it all plays. So if you can start the animation. Great. This is going to be a drive simulation of how all these 4 different operating modes work, 2 in EV and 2 in extended range. We're going to build the car here from the battery, which is the dynamic and full capability as an EV. 8 DC cables go to the traction inverter. The traction inverter again converts DC to AC to the drive unit through AC cables. The drive unit will show up here, and the drive unit is from a powertrain guy's perspective, the heart and soul of the car, coming out to the wheels through these half shafts. The engine, again, sits in here on axis configuration, and we have the fuel tank, 9.3 gallons of premium fuel to run the engine. Now let's look inside the drive unit, the electric drive unit. Again, here's the traction motor, the generator, the gear reduction. We're going to look inside, and the engine is behind it on axis. We're going to see the 3 clutches, the so-called C1 that grounds the ring gear, C2 that connects the generator to the ring gear, and C3 that connects the engine to the generator are inside the electric motors, hydraulically actuated. And we have the motor, generator, and engine speeds shown over here. So now we're going to drive from 0 speed up to 30 miles an hour. First, we have to actuate that C1 clutch. C1 clutch grounds the ring gear and allows the electric motor to drive through a 7-to-1 gear reduction. The electric motor turns this planetary on the sun, carriers the output. Now we're at 30 miles an hour, and the motor speed is shown here. Now, if I want to continue to drive and accelerate, I'm going to pull energy from the battery to do the acceleration. So it's not going to be a buzzy sounding affair. We're going to pull energy from the battery and accelerate on up to 70 miles an hour. And at this point in time, we're a full EV up to 100 miles an hour at wide open throttle and all these conditions. Now, at this point again, at 70 miles an hour, the motor's running 6,500 RPM. And it's not as efficient as we'd like it to be, so now we're going to transition from a 1-motor drive to a 2-motor drive. And simply put, bringing on the 2-motor drive, we first take the motor and attach it to the ring gear, and then we release the ring gear from ground. That allows this motor to now react that torque and change speed. The generator comes up in speed, the electric motor, traction motor comes down in speed, and we're able to operate as a 2-motor EV drive at speeds and loads that are very efficient for these electric motors. And we can drive this way and gain 1 to 2 miles of EV range. Now the battery's down on charge, and we're going to drive again in series operation. Same kind of thing. We're going to apply the clutch, launch the vehicle as an EV. Then we're going to apply C3 that hooks the generator to the engine, start the engine with the generator, and pull the engine up to speed so we can maintain charge at 30 miles an hour. The engine is providing the power to maintain the charge of the battery under this case, and on an average basis. So dynamically we'll pull from the battery, and then on an average basis the generator and engine will provide the average power needed to drive the car. And now we're going to accelerate up to 70 miles an hour again, not pulling a lot from the engine and generator, but pulling mainly from the battery. And then the engine and generator come up a little bit in speed so that we have a charge balance on the overall system. The motor here is operating at high speed. Again, we'd like to be more efficient. So we're going to then make a change from the series operation, 1-motor driving, to the combined 2-motor operation. This is a little bit of additional shifting elements that have to happen to do this transition. So series to combine, we're going to release the engine. We're going to apply the clutch that connects the motor to the ring gear, release it from ground, synchronize speeds, and then hook up the clutch again so that the engine and generator are operating together against the traction motor in this combined mode of operations. Now we have a more efficient drive at highway speed conditions, and this is worth 10 to 15% in fuel efficiency on the highway. So we like this, this combined operation a lot. If we go on a grade, we need more power out of the engine and generator. Again, it's balanced against the traction motor, and the engine and generator speeds go up and the traction motor comes down. And that balance along the planetary gear set is what allows this to happen in a smooth and efficient way. So that is the simulation of the Voltec drive. You can click out of this and go